So in this video we're going to talk about the product and quotient rules for differentiation. I once again don't have any notes, but hopefully it'll go okay. This stuff, once you get it, is fairly straightforward. And I'm not going to go through the proofs of them because generally they're really not straightforward in the sense that they're obvious. They're really not, and it would take too much time, and it's not worth it. Unless you're really interested, like I was when I first learned this, you don't need the proof. Basically, the whole point is but before I start this, I want to say that this video assumes that you have the knowledge of using the chain rule of differentiation, which I will make another video on soon. Basically, you have some function. Let's just call it h of x, and h of x is actually equal to the product of two other functions, f and g. An example of this would be x times e to the x. Okay, this is, if you were to call this h of x, then yes, it's a function of x, but it's also a function of two other functions. So f in this case would be x, and g would be e to the x. Now, this is the product rule, by the way, we're doing right now. It just amounts to, when you do the proof, what comes out of the proof says that if you want to find the derivative of, and I'm just going to drop the of x, if you want to find the derivative of fg prime, then it is equal to fg all prime is equal to fg prime plus f prime g, or fg prime plus g f prime, but there's a symmetry. Or I always say the first times the derivative of the second plus the second times the derivative of the first. So there's like a pattern going on, and that's basically it. It's basically, so if we were to take our function we had before, x e to the x, then it's basically the derivative of that. Let's just write it as the good old d dx. Derivative of that is following this formula. This formula right here. Derivative is it's the first times the derivative of the second. So the first is x, and the derivative of e to the x is e to the x, and then plus the derivative of the first times the second. Well, the first function is x, so the derivative of x is 1, and the second is e to the x. So that's your derivative. You can, if you want, factor out e to the x, and you will get this as your derivative. Not so bad. If we were to do another one, d dx of sine of x, cosine of x, and again, these are off the top of my head, but I don't really need notes for this. By now I've been doing the product rule for like years, essentially. So same thing. It's the derivative of the first. The first function is sine, the second function is cosine, following this notation. So it's the derivative of the first, cosine of x, times the second, cosine of x, plus the first, sine of x, times the derivative of the second, which is negative sine of x. And you can simplify this into, this is cosine of x, or cosine squared of x, minus sine squared of x, and I believe this is a trigonometric identity. If I'm not mistaken, it's no, I don't even want to say what I think it is, because I will probably be wrong, but I mean, it's not important. This is the derivative You can simplify it if you want to put that identity there. It's not the Pythagorean identity because this is a minus. If it was a plus, it'd be Pythagorean. Let's do another one. So it will be, so let's say d over dx of, how about x squared ln of x. Okay, well, the same thing, derivative of the first, which is 2x, times the second, ln of x, plus the first, x squared, times the derivative of the second, which is 1 over x. Now, so you can actually simplify this to just be x, and that's pretty much it. That's your derivative right there. You can, factor out an x if you want. So that's pretty much the product rule in a nutshell. You could get harder problems where if you get x times the square root of like x squared plus 2, where in this case, when you do the derivative of this function, you need to do the chain rule. And like I said, this video is assuming you know the chain rule. I'm going to do another video on the chain rule. So if you do this, is the first x times the derivative of the second. The derivative of this square root function using the chain rule, let's see, it's going to be 1/2 x squared plus 2 to the negative 1/2 times 2x. Then you get these 2's cancel. I'll move this x in front. And this actually gets kicked down to the denominator because of this negative power. So that is the derivative of the second term plus, and you can check that. I encourage you to check that and see if it's indeed right. Again, I'm doing this without any notes, so hoping I didn't make any mistakes. That looked good. So we have now we have the derivative of the first times the second. Well, the derivative of the first is just 1. So now we just have the square root of x squared plus 2, and you could simplify this a little bit, and you get x squared because you bring this x inside. You can actually combine fractions here, and if you combine fractions, you get there. That's what you get when you combine fractions. Again, check, because you're going to have to multiply this term, top and bottom, by the square root of x squared plus 2, which makes this the square root of x squared plus 2 to the first power. And then when you do that, you can now combine these two, and you get 2x squared plus 2. And that's your derivative. So you see how it gets more complicated. Then you get other ones where you might have to use the product rule more than once. Like, say you have the product rule can be extended. If you have FGH prime, it's going to be f prime gh plus fge prime h plus fgh prime, like that. Do you see how it's the same rule, except now it's with 3. So that's pretty much it for the product rule. It's all just robotic. It's just one robotic process. Okay, we'll move on to the quotient rule now. So if we have h of x is equal to f over g, let's write h. Again, you want to find the derivative of this quotient of functions. An example would be x over e to the x, like that. Then, going through the proof, which I'm not going to do here. What comes out of the proof says that you need to do the following. So f over g prime equals, it's going to be g f prime minus f prime g over g squared. and that's basically it. That's the rule. You just follow it. It's just the bottom times the derivative of the top minus the derivative of the top. No, got these mixed up. Minus the top times the derivative of the bottom over the bottom squared. Now, in the first case, when you had the f prime g and the g prime f, it didn't matter which one came first. But in this case, it does indeed matter because you're subtracting. And the one that always comes first is the one with the denominator that's not primed. So, remember that. Just remember this formula. An example would be, as we said before, x over e to the x. That's going to amount to, when you do it, it's going to be g. The bottom is g, the top is x. It's going to amount to e to the x. It's the bottom times the derivative of the top. The derivative of the top is 1. Then the top times the derivative of the bottom. The derivative of the bottom is e to the x. X times e to the x, you're going to get that, over e to the x squared, which is e to the 2x. So now we can actually cancel an e to the x, so we get 1 minus x over e to the x. That's your derivative. Alternatively, you can bring the e up, x e to the negative x, and do the product rule. This is also a viable option. Sometimes it's quicker, sometimes it's not. Whatever way you want to do. It's actually possible to actually never use the quotient rule and always do this and use the product rule. That's fine as long as your question doesn't say use the quotient rule to find the derivative. So, don't just totally throw the quotient rule out the window. So, let's do another quick example. How about sine of x over x? Want to find that derivative. Really important function, by the way. This comes up a lot. It's called the sinh function, oddly enough. But anyway, you got to do the same thing. You got to do the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square. And that's it. That's your derivative. Again, it can get more complicated, like when you have composite functions in the top, or like when you have x squared plus 1 squared over x. You need to now do the chain rule, or sometimes this might be, sine x. So now you would need to do the product rule and the chain rule when you take that derivative. But let's just stick to this one. So be careful of that. Sometimes it can get complicated. This video isn't meant to show you every single type of example because it would be like 2 hours long. So this is just the gist of how to do it. Doing this one quick example is going to be x times the derivative is the bottom times the derivative of the top. The derivative of the top is going to be 2x squared plus 1 times 2x. So it's going to be 4x squared. And then minus the top, x squared plus 1 squared times the derivative of the bottom, which is 1 over the bottom squared. There you go. That's your derivative. You can factor out that x squared plus 1 if you want. And that's pretty much it. So there really isn't that much to the product and quotient rule than this. You basically just follow this formula, and that's basically what it amounts to. So, thanks for watching, you guys. Yeah, see you later.